Okay, so amortisation and sinking funds, as we saw in 8.6, this is all about depreciation. So over time, things, machinery, whatever it is, most things lose value over time. Some rare things don't, but most things lose value over time. We have two methods of depreciation. Linear depreciation, or prime cost, which means that it depreciates by the same value every year. So my car depreciates by, say, $1,000 a year. Limitations with that model is that if you follow a linear function with a negative value for long enough, what's it going to do? It's going to go negative, and things can't... Boats and cars can cost you money, I guess, but they won't get negative value, correct? It's impossible to get negative value. And then diminishing value, which is far more common, is where it depreciates by a percentage each year. And that's when we use our formula A equals P, 1 minus I, so whatever your depreciation value is, to the power of n. Cool. I put that first equation, A equals P minus D, but I wouldn't even worry about that. I would just use common sense. If you're losing $1,000 each year, how much value have I lost in 5 years? 5,000. Okay, so that's how I go about my problems with straight line depreciation. Scrap value, okay, it's just more of a vocab thing here. Scrap value is how much an object is worth at the end of its usable life. So if a printer or a car is supposed to last 10 years, the scrap value can obviously be taken into account and taken off the amount required to buy a new one. Happy with that? So if I get $1,000 off my car for scrap value, when I buy my new car, I can take $1,000 off the new car. And that can be accounted for in sinking funds. So sinking funds is money that we put aside each year or at regular intervals to cover for the cost of replacement. So if I know that I need to spend X amount of dollars to replace something, I use my annuities to find out what should my payments be. Cool?
So like saving for a new car.
Yeah, saving for a new car. So if I know I need $27,000 for a new car as a business, how much money should I be putting aside each month to cover that cost at the end of the 10-year period? Cool? Happy with that? That's financial mathematics.